Oh, actually, you know what? The dike and the dimensions can actually hold all of the liquid. Okay, never mind, I didn't calculate this exact one. The dike as I have calculated it, to contain this leak, it actually can take the whole. Even if the hole is down here, it can actually hold the whole liquid. So we're not, right, we're not at risk to do that. Okay, so what do we need to look at? Okay, so what we need to calculate is the velocity out here, okay? Because we need to know, right, at a distance now, 2 meters from the tank, where is the liquid, right? Because the dike wall will have to be tall enough to contain that. And I'm sure you're gonna realize that it's gonna need to be close to 6 meters, right? Just like in the other example. Okay, but in this case, we have U equal to our C naught. Gauge 10 to the 4 pascals. 10 to the 4. The density was given. Note I'll put it in grams per cubic decimeters, which is equal to kilograms per cubic meters. And then we have it is 9.81 meter per second squared times 10 minus 6 meters. Okay, so we have assumed full tank. That gives us worst case scenario. Okay, so that's 2 times that. Okay, so that would be, right, when C1 equals to 1, that would be a worst case scenario, but even if we go, this is probably most realistic, we get 6.214 meters per second. Right? Okay, so geometry now, it's coming out of this hole at 6.2 meters per second. So in 2 meters, right? It takes 2 over 6.214 equals 0.32 seconds to reach the wall. Okay, and that means that is you do 2h, let's call it x for the distance. So g equals t gives us that our x in this case is 0.508 meters. Okay, so up here, the liquid has dropped 0.508 meters. That means that the wall has to be 6 minus 0.508. Has to be 5.5 meters high.
For a worst case scenario, would you want to assume that the water is like shooting up at a 45-degree angle? So that would like increase distance. I mean, or was it just straight out?
So the question is, for worst case scenario, are you gonna, do we want to assume that it shoots up that way? No, let's just, you know, I think that would be highly unlikely, actually, that it's coming out at too much of an angle, right? That would only be if you have a pipe that goes like this, right? If you have a pipe that goes like this and it breaks here, then it would shoot. If you just have a hole, it would come out pretty straight.
Why does, when you shoot out of a hose, it doesn't come out straight? I don't know.
It's gravity.
Well, I'm thinking like you have a forklift and it like maybe pulls a little part of the metal back, so the metal's like hanging off like that. And it's like,
there are a lot of there are a lot of variations in this one. Let's and I would say let's, you know, simplify it so we can handle it easier.
okay.
Right? Because if we start adding, you know, constraints like that, then right. Then it makes it a little bit more difficult to handle. So what were you saying, that it's not coming out of
Like when the stream comes out of something, it doesn't
Yeah.
come out and like stay as a perfect stream. It comes out and kind of sprays everywhere.
well, that depends on your nozzle, right?
But like when you get a hole in something, you're not gonna like.
It sprays. It's a pressure too, right? That just makes it go, and then it comes right. So it comes out, and then it just expands at the same time. So that's probably the pressure. It goes from a high pressure to low pressure. So you have the expansion of that at the same time. But if you have enough liquid and you have, right, a whole lot, it's gonna be pretty. It's gonna come out there at a significantly high pressure, and you know, goes straight for a while. It obviously is dependent on the velocity coming out of here. But in other words, what does this tell us? That really a dike really needs to be designed to hold all the liquid. It will not be possible to design a dike that can hold, right, if you get a hole in the tank at any level, because if it's up here, right, it's really hard to contain it, because the dike will almost have to be as tall as the tank, or humongous, and that's just not economical, right? That is not something that's possible.
If you have a dike there in the first place, why is it reasonable to take away the function?
2 feet isn't that much.
It depends. You'd be surprised.
Oh.
You'd be
That's like our
surprised,
height.
because
That's
their
a pretty good
constructions,
system.
they're
That's a good
working on
system.
one
That's
of
actually
these,
a
right?
whale.
And they have this
7 feet.
swing this bar across, and it goes shh.
It's just a
Right?
bad
There's a
operator.
lot of, you know, any lifting motions and this swing around, there's a lot of torque and a lot of, yeah. Some of those questions we just shouldn't, you know, ask, because it's,
Increase the dike wall by
you know,
half
you
of
just
what
use
happened.
logic and you can see that things like this shouldn't happen.
Hey, Dan.
But
Swing by the
But-
tentacles.
it's like all of the, you know, all of the startups in plants where they've left 2x4s in the pipe, right? And they're having problems during the startup. You know, things happen when you deal with humans, I guess is maybe the worker was came back from a 12-hour shift and working the crane, So, now right, things like this shouldn't happen. You know, for all we know, there could be a bullet hole too. I mean, stranger things have happened. I think that has happened in the Trans-Alaskan pipeline, right? Hunters hunting for deer and just actually shoot a hole in the pipeline. You know, I don't think I have a whole lot of time to start a new problem. So the next one I had was 438.
Is the TA coming today?
That is actually one of the suggested problems. So, you know, you will have solutions on that.